All right. Do that again just to make sure. Okay, so right, we're back now. So if and when Ashley shows up, we'll redo the in class portion of the test, or not redo, but we'll hand the test back out. I have both of the students up here. I have your tests, and we can go back over those. And so we won't actually go over the tests, like review them, until next week. But you all can continue working on the tests. I'll give you another hour or so. However, if you don't want that time, you can just turn it back in. So maybe it is better to do it at the end of class. So you can just take off at that point. Now, I did want to talk really briefly about the take-home portion of the test. Okay, so I've graded the take-home portions of the test, and what I did was that if you got full credit, in other words, I graded them by bringing them into ArcGIS and ArcGIS Pro and running the tool in the toolbox and matching up to see if I could get the same output that I created in the example video. And if that ran successfully, you got full credit. So there were probably about half the students that their tools worked and it ran well. And so basically, if you have an actual grade for that assignment, it indicated full credit. If you don't, I made a comment and told you where you could improve. So since the in-class portion, we're gonna get a little bit more time on that. I'm also going to give you a little bit more time on the take-home part. Now, to be fair, the people that turned in one that totally worked will get a perfect grade. And if you revise yours and turn it in, and it starts to work, you won't get a perfect grade, but you will still be able to get a high grade if you turn it in and it's working. Now, I guess I should. Maybe after class, I'll go in and assign a grade that you would get if you didn't make any changes. I can do that as well. But we're gonna go back and give you another week to complete that if you like. So that's for the written portion of the test. And those of you who've done it successfully, it really is only 10 or 15. I mean, depending on how you write it up, it's not that much lines of code, right? So just to review, and I said this in the comments. So just to review, you just need to collect the appropriate parameters, which are you need to find out which two data layers the user wants to run it on, and then you need two distances, one for each data layer. You run a buffer on each data layer with the distance that they specify, and then you do an overlay, but the overlay needs to be a intersect. So you do an intersect on the two buffers, you write it out where they specify to get full credit, and then you get full credit. Yes, Jordan.
Is there any way of you going through another example that's like not like the one on the test, but kind of similar, as into how you would set up the parameters? Or can I come to you after class?
Yeah, I mean, you're welcome to come. You're welcome to talk to me about it. We did do it. There's a video that's already there because we did it the week before.
The one with the one for week 4.
Yeah, the one that used the census tracks. I mean, sorry, yeah, the census the block groups or census tracts, and the watersheds.
See, I'll watch that one a bunch of times and still kind of have me a little bit confused. But I'll get with you after class or something. If that's
Yeah, yeah. Or if I have time right afterwards. Anybody else have a? I mean, I guess there are some other people that have a similar question, but I can, yeah, I can create another video on that. But all right, so that's the test. I think it's getting a little warm in here.
Door open probably.
Did you turn the air up or down? Or?
I'm saying the door being wide open probably.
Oh, that's fine. I'm sure that's fine. You don't need to close the door. I'll just take my sweatshirt off. Okay. So 2 weeks ago, we started talking about. What you can. 2 weeks ago, we started talking a bit about accessing individual components or individual rows in a vector in the vector data model in GIS. So tinkering with the attributes and accessing them. If you remember, I'm going to go to the web page for this class. So that was M6. Okay, so I'm meeting 6. And I didn't actually change the outline too much for today. Okay, so really this is an extension of this lecture where we talked about working with vector GIS data, and specifically it's a continuation of the data access model where we talked about doing using cursors. So we talked about 3 different types of cursors: the search cursor, the insert cursor, and the update cursor. Now we really only did search and update, I'm pretty sure, right? What does a cursor do? What does it allow us to iterate through? Like when we get a cursor and we say, and we create a loop. What kind of loop do we create when we create a search cursor? DA, ArcGIS, ArcPy, search cursor. There we go. All right, look at some of these examples here. They're saying while arcpy.da search cursor as cursor, with, yeah, for row in cursor. So they kind of gave it away right there, but each item is a row. Okay. What's a row? Yeah, it's horizontal, but what does it represent in the world?
Data in columns. You go there in columns, and all the data lines up in columns. Consists of rows.
Each row in a GIS system. I'm gonna go ahead and open some GIS data here. Hey Ashley, how are you?
Doing well. I was next door in the science building, and Miss Christy Knoll said that she didn't get them. So that's why I was over there trying to find them, and she was calling the receiving person, and he didn't answer. So she's gonna call me whenever she gets in contact with them.
Okay. All right. Well, I guess worst case scenario is it just happens next week, but. Yeah, I put them in campus mail on Friday, so I was told that they should get there. They told me up here the campus mail runs on Monday, Wednesdays, and Fridays.
Yes, and that's what I had told her, and I actually checked yesterday around 4, and they weren't there either. So that's why I came back this morning, and she was like, it's still not here. She did say sometimes they get delayed and they come in Tuesday, so she might get them still.
Okay. Well, if she gets it, we'll do it at the end of class. If not, then we'll do it next week, I guess.
Okay.
That sound good? Or I'm fine with you all getting together at a time of your choosing and doing it at a different time. You know, I just want everybody to have the same amount of time, and it doesn't have to be exactly an hour. It can be a little bit over an hour, but not like a crazy amount of time.
Okay. Yeah. Well, if I get a hold of them after class, I can email everyone and kind of set it up.
Okay, that sounds good. So, just really quickly, Ashley, I mentioned that, and this is recorded on the video. I mentioned that I was giving everybody an extra week on the take-home portion of the test too. But if you've already received a grade and it's 100, there's really no reason to do that.
Okay. Thank you.
All right. Okay, so I'm going to download some of the data for this. So we're on M7 right now, and I've got two different data sets in here. I've got one that represents all the states in the United States, another one that represents all the cities of Mississippi. So I'll go ahead and download both of those and put them in a directory. These are shape files. They're not file geodatabases. So a little different than some of the data we've been dealt with before, but that's one of the great things about ArcGIS is that it abstracts that information. So we can access shapefile very similar to the way we would access a geodatabase. So I'm gonna put the data that I just downloaded into this folder here. And then open it up in ArcGIS Pro. Okay. See, temp. I chomped on my tongue last night, so gotta be careful. All right, there's our data. I'm not sure why it came up so weird. Looks like that looks like the projection is in MSTM. So the city's data was in Mississippi Transverse Mercator. So these are all the cities in Mississippi, and that's what looks like it turns the whole map into that. I could modify that by changing the coordinate system. Yeah, right now it's in MSTM. I could change it back to Web Mercator, which is the default. So now I've got put the cities up here. All right, so here's all the cities of Mississippi. And obviously this is a little bit, this isn't like yesterday's data or anything. But you know, here on the coast, that's Gulfport. And this little guy right here is Long Beach. So y'all are in Long Beach. This is Pass Christian and so on. Right? Okay, so I'm going to talk a little bit about accessing this data using Python. And what city is this, by the way? D'Iberville, okay. And review that. Okay. So last week we talked about a few different ways to do that. I'm going to use IDLE. I don't know why it doesn't show up. Yeah, usually, maybe it's just under ArcGIS Pro. No. But I do know that it'll work by, if I go to where I want to create it, documents, no, users, C, users, George, courses. This way it'll be created and you'll all be able to see it on GitHub. But if I right click and I make a new, that's not what I meant to do. If I make a new text document and I rename it example 1.py, and I'm going to name it example 1 underscore 2019.py, and then I can right click on it and say edit with IDLE, and it'll open up. Okay, so I want to access the individual rows in my GIS database. In other words, in a GIS file. How do I do that? Well, if I just want to look at them and inspect them, then I use a search cursor. Okay. Anybody remember what an update cursor would do? Yes, it allows me to change values, and then insert allows me to put new records on the bottom. That's what those three different ones do. So I've got the help up for search cursors right here, and you know, there's no, for the second part of the class where we're doing Python for ArcGIS, there's no book provided, right? This is your book. These help pages are the book for ArcGIS Pro ArcPy. So if I want to get the data out, I need to create a search cursor, and here's an example down here of creating a search cursor. So we need to provide the search cursor a few different things. So search cursor is a function. So we need to import ArcPy, and we can optionally import arcpy.da, but we could also just type in arcpy.da.searchcursor. Okay. So to create a search cursor, we need to decide what we're going to name it, what our search cursor is going to be. Cursor is just fine. Cursor means that, that's a variable name. So we're calling it search cursor. We can name it whatever we wanted. We can name it Bob or Bob cursor, cursor 1. I'm going to call it cursor 1 actually. Cursor 1 is equal to, I'm going to take this, so we're creating a search cursor, and the two parameters, well, it needs more than, it can have more than two, but it's going to have the input table as the first parameter, and the second parameter is a list of fields. You can just give it an asterisk, which means I want all of them. So we did this a little bit last week. And I'm just going to say, for the fields, I'm just going to, again, ask for all of them. But FC, for the feature class, let's say I want to get this Mississippi cities GIS layer. That's the feature class that I want to deal with. How would I get that? How would I get that into my script? What do I need to find, Jordan?
Would you right click on cities and go to properties and find out where you saved it?
Yep, that's definitely one way to do it.
But how would you use the Mississippi button?
The Mississippi, I do the same. Oh, you mean just the state of Mississippi?
How would
Well, I only have the cities in Mississippi already.
Oh, okay. Never mind.
So I don't have the cities for everywhere.
Oh, okay.
But that is a great question. So Jordan's asking, let me put this R in front of it. Jordan asked, how would I get just the Mississippi cities if I had all the cities? You can do that as part of a search cursor. If we go back and look at the help, that's the third parameter, is the where clause. So I could here say that I want just the just a certain city or just certain cities. Let's look at the attribute table here for the cities. What attributes does it look like we have? Well, we have a name. We have a bunch of weird variables. I don't know what those mean. We don't really have population. We should have, well, we don't really have area. Why isn't there a shape underscore area field, by the way?
You didn't run a tool on it. That's what usually makes those, isn't it?
If we're talking about a shape field, yes. The area usually is created in a shapefile. It's created by the user. So you would create that. All right, that's the way it's created in a shapefile. How about in a file geodatabase? All right, so the correct answer is in a file geodatabase, the shape area and the shape length are just there. They're unless it's if it's a polygon shapefile, there's a shape area field. It creates it for you. But in a shapefile, it does not create that for you. All right. Well, if we only wanted to get one city out, we could make a where clause and say where, or not where. Sorry. We'd have to make sure that we get the query expression right. So it doesn't look like we put it in parentheses. Where, not state name because we won't have that variable, but name 10 I think was what it was called. Let's look over here. Name 10 like nat. What this is going to do is try to find anything that starts with NAT, and in SQL the percent sign is actually a wildcard.
So you wouldn't have to spell the whole city?
Yeah, or any other. This would actually return any city that started with NAT. And then this needs a close quote to finish it. So you need a double quote to finish and to start, and two single quotes there. All right. So how do I iterate through a cursor? A cursor is like a sequence. It's a sequence-like object. I want to get each row and inspect it a little bit more. How do I do that? What kind of loop do I need? 4. That's right. 4. And I need to come up with a variable that represents each row in the database. Row in cursor 1. Print row. I'm going to run it. And it's created that row. And look, it's only giving me one row. Okay, it's just Natchez. I wonder if there are any other cities in Mississippi that start with N. Can you guys think of any others? I don't know off the top of my head. Yep. So Natchez, New Augusta, New Hebron, New Albany, Naxapater. New Haluka, Nettleton, Newton, North Carrollton. So we've just iterated through all of those. All right. So that's with the where clause. If we wanted every single last one of them, we could get rid of the where clause or just say name like percent. Okay, I don't know why you do that, but in other words, the where clause is going to return everything because it's just got a wild card in there. So now that's all the cities in Mississippi, at least according to when this data was published.
Is there a way to format all that so you can get some quick and visuals of what you're looking for? That's a lot of work.
So, like, what are you looking for?
Well, it kind of look at anything, but those have a reference for cities, they have them in a column, but they also still be roads too, if you line it up right.
I'm sorry?
If you line it up right, like I said, you take care of it, if you look at something, it's like this flow. That way you can line that up to go in columns and also rows.
Well, yeah, so the only way to do it is to the only way to do it with this data is to format it yourself, let's just say I was only really concerned with the name column, then I could change it so that instead of saying print row, I only printed out the name column, which was 0, 1, 2, 3, 4, 6. Then I ran it. Now I'm only going to get that name column. That's going to print out all of those guys. So that.
I was thinking that's probably looking for that you were just looking. I was wanting to line it up so I was just looking at it.
You can mark it by the spaces and leave it that way. Or like by commas. Remember, I forget the actual name for it, but when you break the list by character, you can do it by comma, and it would make it more organized.
Yeah, because right now it's what data type is row? Row is it's like a tuple. So all this stuff.
Right.
Yep. So you could say something like print row dot. Is it join? Is it something like this? It's got to be join tuple Python into string. Well, that's what we did.
Wait, but you had parentheses around it.
Around what? Well, I'm just printing the whole thing,
Oh, okay.
so that should work. Yeah. Yeah, I mean, there are more efficient ways, actually, is what I was getting at, is that if we want to just see part of the data, there's better ways to do that, which we'll talk about in a couple weeks. You can basically take the data set and turn it into what's called a pandas data frame. And once it's a data frame, you can query out parts of it and just show the first 5 records, just show the last 5 records. You can show only the columns you want to show, that sort of thing. But we're discussing search cursors this week. Cursors this week, and now we're gonna talk about reading and writing geometries. So, so let's go back to the help here, and we're gonna look at the the geometry field right here. So notice that if we just print this off the way it is, I'll run it one more time just to show. If we run this off the way it is, the shape field is the second field. So look at what it's returning to us in the shape field. That's this information. I should have only printed some of the cities. It's almost done now. Okay. So that's this information right here. Okay. That's just a coordinate, an X and a Y coordinate. Does that represent the geometry for Gulfport? Yeah, it's a point. It's a centroid, right? So in order to get the entire object, we need to feed it in our list of fields. We need to feed it. We need to feed it a special case of the shape field where we just write shape at, and we'll get the geometry object for that feature. Okay. So if I change this, instead of getting all of the fields, I just want to get shape at. And is there any other field that I want? I'm going to get the name field. Name 10. So now I'm going to get those 2 fields from the database. Now I'm going to change this so it doesn't print out like every single thing. Let's just do the ones that start with O. I wonder how many there'll be that start with O. Try to pick one where there wouldn't be too many. Maybe there aren't any. Let's just go back here just a second, see if I can still get the same error. Class not registered. Let's make sure my syntax is correct on that, on this one. So let's look at the syntax for feeding it field names. Okay, yeah, my syntax is messed up. I still need quotes around the things, not, I put it in the wrong place. So right now I'm giving it literally bracket shape at comma name 10 bracket. It wants a list of strings, so these go inside. So I messed up. All right. That's the problem. I think it'll run pretty quick just like this, but we'll see. Okay, so now it's, yeah. So now it ran through, and each instance is a polygon object, and the item that's in there is, I mean, the shape, the name 10 is right next to it. So we're only getting two things in our tuple. We're getting the polygon object and the name 10 value. All right. Now, what is a polygon object? Well, that's something that we can look at back in the help here. Go up here. It's going to return a geometry object. Notice that there's a hyperlink there. The geometry object is hyperlinked. We can click on it, and we can see that this geometry object is actually a superclass, meaning that there are multiple types of geometries. There are multi-point geometries, point geometries, polygon geometries, and polyline geometries. So there's all of these different types of geometries. Now, which one did it say it was when we ran it? Polygon. So we click polygon here. We can here look at all the properties of a polygon object. We can get its JSON representation. We can get a few other different representations on WKB or WKT. These are OGC, which stands for Open Geospatial Consortium, representations of that object. Let's look at those real quick. Again, I'm going to change this to just O's so it'll run faster. And instead of printing just the row, I'm also going to print the row 0. What's in 0 now? What's in row bracket 0 bracket? That's the first what? Yes, it's the first field. It's the value that's in the first field. So in this case, it's that shape field. So in all cases, we know that's going to be a polygon. So when we say row, and then row 0 dot, and we get the property that we want, in this case JSON. And now we're going to run it. So it's going to print out the row, and it's also going to print out the JSON representation of that row, which is going to look really big. That's why I only did the O's. Oh, I didn't. It did print more than just the O's.
Then you put P in and not O.
Oh, I did. I put P in and not O. You're right. Thank you. All right. So run it. So there's all the O's. And it says it squeezed 56 lines of text. That's one of the things that it does. If you double click on those, it'll expand them and show you what is in there. So what is in there? What does all this stuff represent? These numbers. What do these numbers represent? What's that?
Like where the points of the polygon are, so where you can make the shape?
Yes. It represents where all the points are that were used to create that shape. Yeah, go ahead.
Hey, what does ring stand for?
What does what stand for?
Rings.
Rings. That's a great question. So a polygon is an entity. So let's look at anybody know where this city is? I don't know where that city is. Anybody know where it is?
No idea.
It's right there. Right there on the border of Louisiana. And it's a square. And obviously it's a little bit mismatched because some of it exists outside of the state, which isn't right. Okay, so this is a fairly simple polygon, right? If I click on this, if I go to the editor right here, and I modify, see all those individual vertices that were used to create that created that. Oh, I can't move that off. If I move that down, yeah. Okay, so see all those all these are individual vertices that were used to create that town boundary, If I go into here, I can see those coordinates, 92.96 and 02.58.
So all of those are XY coordinates to make that shape.
Exactly. Now, these coordinates are all in now Web Mercator, not WGS 84, and ArcGIS takes care of handling that for us in the background. But yeah, all these values were used. All these points are all these points right here. All these points. Okay. And a ring is what you think of as one polygon. So how many rings are there here? Well, there's just one ring. Okay. In fact, we could, to go back, I'm going to stop editing here in case it causes a problem. Edit. There we go. I think that stopped editing. Okay, so then I'm going to come back over here and say, get a different attribute. Instead of the JSON, I want to get the part count. I think there is a part count. Yeah, part count. So now, instead of JSON, I want to get the part count. I'm going to run this again. Okay, look, the town we were on only has one part count, but Oakland has 2 parts. What do you think that means? Anybody been to Oakland, Mississippi before? I haven't. I don't know where it is. Let's find Oakland. You know where it is? I didn't grow up in Mississippi, so I don't know all the little towns. I've been around a little bit, but Oakland. Where is it? How do I stop editing? I thought that was what I was doing earlier, but it doesn't look like I did it. Modify features. Yeah. Okay. I guess I'm out of edit. What minute right here? Okay, we're in Oakland right now. Looks like it's. Let me turn off the states here. Looks like Oakland is in Yalobusha County. Right here.
Is it 2 parts to Oakland?
Yeah, look at that. See, there's one part here, and there's one part here. See that? I don't know why it does that. I didn't even know that was like legal, right? But it's definitely legal for other polygons. Like if you had the state of Hawaii, how many parts would it have?
Wow, man.
Yeah, however many islands there are. I'm not sure, but Oakland has 2 parts to it. The city of Oakland. They incorporated this square here, and then they incorporated up the road. They incorporated right by, it looks like the 55 freeway. Probably because there's like a gas station or something that wanted services. Yeah.
So what if you had like a bridge separating it, like let's say the river was going through, if that was still the part of that town? Is that possible?
Yeah, cities can incorporate. Well, there are some restrictions in some places, but like the city of San Diego actually incorporated out into the ocean, and then incorporated because they're supposed to be contiguous, but it incorporated out part of the ocean, and then incorporated the area just by the border is also within the city of San Diego. But technically, it's contiguous, but some of that isn't even land that it incorporated.
And then talk about annex, they can annex something that is like here in London, in a London, kind of in a fast food is trying to annex 4 things. They got things themselves, so they make themselves a part of the Pasadena area.
Right, and cities can annex each other. Like, I was born in Hollywood, which was at one time an independent city, but now it's part of Los Angeles. So, yeah. Yeah, all those questions about city municipalities. I mean, I'm not an urban geographer, but yeah, here's another weird one. Pelahatchie. Look at what they did. They incorporated all of the area along I-20 going east and west of their town, right? So why do you suppose they did that? I don't know exactly. It could be because they wanted the speeding ticket revenue. They can post.
There's gas stations or
Yeah.
along the way.
Right, money stations could bring money to that city, you know, stop there and do like the other stuff.
Right. Yeah, I was just about to say it's more likely that they did it in anticipation of future growth, so that if there are developments that ever happen along the freeway, they'll be what do you call it? They'll be part of Pelahatchie for their tax base. Okay. So they're basically preemptively preventing Brandon from doing the same thing for any developments that exist between these two.
One on the right side, that was the same way.
What's that?
Like, scroll to the
Yeah.
right.
So whatever this one is, they did the same thing a little bit this direction. Morton.
It's more cheaper to do it your road network than just try to get a whole bunch of land because you're responsible for the upkeep. They can do that down piece, get all their money in just from that, but they can get a large swath of land that they're responsible for.
Yeah. Then they're responsible for providing services and that sort of thing. My guess is, I don't know for sure, but at some level they're responsible for providing, fire and whatever services that happen along this portion of the freeway. So yeah, and that's that's not super important to what we're talking about, but yeah, I mean, cities look weird in some cases, but my guess is Pelahatchie is still only a single, even though it's weird shape, it's still only a single polygon. See how it even gets really thin here, but it's still only a single polygon, and that was different than Oakland. Oakland was 2 polygons, right? Are there any other cities that are 2 polygons? Well, we could find that out by just changing this back to all of them and rerunning it. See if there's any other cities that have multiple polygons. Jackson has more than one, as does, I saw another 2. Ethel, and how would we print out, what if we wanted to print out only those cities that had a part count that was 2? What could we do?
Okay. Couldn't you say, at the park count, you put some kind of list after that, where it would be, would you put it here? At the park count, the brackets?
No, if I only want to print out those with part count over 2, or 2 or over, I would just say if.
Yeah.
Okay.
And then I could go if, whoops, totally messed up. If part count equals, or actually it's a greater than 1, then print it. See, now it's going to print just those that are larger. So I run it, and I can see the list of all those that are 2. Laurel actually has 4 parts. Yeah. You guys know where Laurel is? I know where Laurel is because it's near us. I think this is Laurel.
Can you show the code one more time?
I'm sorry, what?
The Can you show the code for one?
Sure. I'm not exactly sure what all the parts of Laurel are, but if we zoom in here, I guess we could see these are actually two different parts. They must be, but I don't know where the other parts are. Maybe these guys are two more. 1, 2, 3, 4 parts. That must be it.
And you kind of see a pattern. If I go with the road instead of this area.
If we modify Laurel, let's see, vertices. So part 1. Yeah. So yeah, there's 4. Oh, this one says there's more parts than that. But anyway, okay, so how did I get out of this? Yeah, like that. So Laurel had 4 parts. Jackson had 2. Okay. Now let's look at, let's go back to the O's here. Now you remember that this city right here, that's GHY, not Ocean Springs. So let's go to the G's. Let's see, that doesn't show up in our list of parts, right? See that? But you'll notice that GHY has some, anybody know the term for these things? I mean, kind of. I mean, yeah, they'd be similar to an island. So why doesn't they show up as separate parts? Let's get GHY here. So G, and then I'm going to delete this part. What's that? Yeah. Right. It could be lots of those. All right. So let's going back to the help real quick. You'll notice that each of these, one of the properties is its parts. So let me just try to find it. That's part count. Get part. So it's a method. We can get a part of the polygon. So let's say get part, and we're going to get the only part that there is. Let's see what happens. So it's returning back an array object when we ask for its part. What's that? GHY's right here.
Oh, okay. Oh, yeah, I forgot.
Yeah, so it's an array object. So another thing about the fundamental units are the points, right? But the points, when they get built up to make geometries, they're actually these objects called array objects. And an array is just a series, or another way to say it is a sequence of numbers. So we could get all of the elements inside of a geometry by doing something like this, by saying for row in row cursor, and then saying for part in here, maybe a better way to do this would be to say row, because remember row 0 is equal to the shape. So we could say for part in shape, or sorry, this is reverse. Shape equals row 0. So this is like a helper line of code where we're saying row 0 is going to be equal to shape. And then that makes our code more readable. For part in shape, now we could just say print part. And part is going to be an array object, another one of those array objects. So now when this runs, it's always an array object. What if we wanted to make sure, let's go print row 1. So now we're going to print, just before each array, we're going to print which name it is. So here is Greenville, and there's the first part. There's Gunnison, there's the first part. Grenada, there's the first part. We go down to GHY, there's one part. So there's just one part in each of those because they're all only one contiguous geometry. We're only going to get 2 lines if we, what was one of the ones that had 2? Jackson? So now when we run this, see how we're going to get, Jackson has those 2 parts. And Laurel, this might be more than one city that starts with LA, but we'll see. Yep. So Lambert has 1 part, but Laurel has 1, 2, 3, 4 parts, and Lake has another part. So we're iterating through these features. So now the part itself has multiple parts, and we could say for ring is what they're called, in part print, let's just print the ring first and see what it is. Yeah, these are the points within each array. So the way it works out is that every polygon object is made up of parts which represent standalone polygons, like contiguous polygons. And then each of those standalone polygons can possibly have another polygon inside of it, and those are each called rings. So polygons are made up of points, which make up rings, which make up polygons, which make up the entire polygon. So polygon parts. So you got points that build rings, rings build polygon parts, and polygon parts are polygons. Now typically, in most cases, in fact, in many cases, polygons are just polygons, right? Like one polygon is just a single polygon that doesn't have constituent parts. But it's really important to know this so that when you go try to access the parts of a polygon, you'll know why you need to say, oh, first give me the first part, and then give me a piece of that part.
So you say a shape, polygon could be a shape file, correct? polygon is the shapefile, and within the shapefile, we got other rings, as you're saying, rings within a ring within.
Yeah. So okay. So the shapefile itself is not a polygon. It's a group of polygons. We say it's a type polygon, but the shapefile itself contains, in this case, 298 polygon records. Each line is a polygon. So when I say in the code here, for row and cursor, I'm getting each line. Each line represents a city in this case.
Okay.
I'm getting a polygon. And then I'm getting out each part of the polygon. And finally, I'm getting out each ring within that part. And that's what I've printed here is the rings that it built up.
So each row can have many rings within those.
It can, but usually unless a ring, like this polygon right here has 3 rings. The polygon that represents, what did we decide this was? GHY? It has a ring that is the entire outline of the whole thing. And then it has a ring that is right here and another ring that's right here. And ArcGIS knows to draw those in that order. Okay? Probably some people, okay, so we've read the geometries out of this file. So some people, this clicks a little bit better when we create our own geometries and read them back in. In other words, we're just practice getting the geometries out, and now let's practice getting them in. In other words, writing geometries out. So if we go back over here to the help, now, I guess before I get there, there are some things that you can do just with geometries. Okay, you can buffer individual geometries. You can clip individual geometries. You can do all of these different things with individual geometries. So, yeah, when we practice when we practice writing geometries back out, this might make a little bit more sense. Well, we can actually show what this looks like if we do that. Okay. All right. Yeah, let's do that as an example, and then we'll practice making them from scratch. Okay. So what does this convex hole look like it does? Like, just describe that in your own words. Like, if this was a polygon and this is the convex hole of a polygon, what does that look like it's doing?
Going around all the outside points.
Yes. There are no, in a convex hole, there are no interior angles that are going in, that are concave. All the exterior angles are convex. See that? And so the convex hole creates a new geometry that is the convex hole of all of the values. Okay. All right, so what would the convex hole of, well, Peelahatchie look like? Or Laurel here? What would the convex hull of that shape look like?
Go from the point where the highway is to the point where your finger was just on.
Yeah.
Yeah.
Then like that and like that. It would never go inward. So sometimes people might use use that for, like let's say in this particular example here, these might represent the tracks of an animal, okay, with a GPS collar on it. And we could say, well, its home range is probably somewhere in there. It's probably not limited to just these areas. And so we could come up with a surrogate for its home range by creating a convex hull. Or if we just had the points, we could do that. So that would be the utility of creating a convex hull. All right. So what's that?
So that's the farthest limit that you could possibly go without trying to trace every trail is doing. It's just the outer limit of that particular.
Yeah, it's the outer limit without drawing any angles that go in, that go in toward it. Yep. So if I save, I'm going to save this as example 2. Okay. All right. So we're going to get into insert cursors. All right. So convex hull is a method of the shape. So I could say new geometry is equal to shape.convex hull. So now, if I print this, it's not going to be that exciting. Print my new geometry. And I run this. It's just going to say my geoprocessing described geometry object. Okay. So for each of the 3, you could even say row 10, or sorry, 1, just to show which one's which. For each of my 3 cities that starts with LA, what's in this geometry object is the convex hull for the city of Lambert. And this is the convex hull for the city that's in Laurel. That is Laurel. And this is the convex hull of Lake. Okay. But right now, we can't see those. Can't see those anywhere. We can't deal with them. I'm not sure if interactive Python would allow us to see them. Maybe just for fun, I'll try it out.
When you say that they are making all those parts one piece, they're not showing it as that, but is it like showing those parts like 3?
Probably the convex hull is going to be one single piece. Just seeing if this prints it out. It's probably just going to print out the same thing. Yeah.
But it's not for showing accuracy of how much land is there. It's showing you the out.
Yep. And we can't even see it right now. It'd be nice to be able to see what we just created. And so, in order to see what we just created, we want to save it out. Okay. We could use the update cursor to modify this data set, but we don't really want to do that, right? Like, here, I'll show you. I'll show that here in a well. Let me take map clear. So if I take the cities 10 data and I export the features, and I'm going to call this cities 10 copy. I don't want to put it there. I'm going to put it in the same location that I've been working on. So that's C temp M7 Oh, well, that the output will be city10 underscore copy. All right, now I run that. So now I have another copy of it. So I can mess with it a bit. So you have another copy of it. Now I'm gonna remove it so that I can't see it there, because if I try to edit it, it will have a problem. Instead of a search cursor, what kind of cursor do I need to change this to if I'm going to edit it? Update, right? Yep, update. And so now what I can try to do, let's see if this works, is say row 0 is equal to new geometry. And then now I'm saving that out. Now there was one more command you had to do when you did an update cursor. What was that? Open up another window. Update cursor. ArcPy DA. You need to run update cursor.update row. So now we're going to take, or we need to say call cursor 1. Cursor1.update row. Okay. So we're going to run this guy, and I didn't have it print anything, so it's just going to run it and be done. Okay. Now if we look at row at city I10 underscore copy, what should we see different about any city that starts with LA? What should the new geometry be, though? What should it be updated with?
Whatever you say it should be, the screen you get on it.
Remember I did the convex hole, and you could see, look what happened to Laurel. Here, I'll put the old, so that was Laurel, and then I updated it with the convex hole of Laurel. See that? Which one? Sure. I'm getting there. Sorry. Apply. There you go. Is that more contrasty?
Yes, sir.
And then I don't know where the other L cities were. I'm not sure where they were, but they're somewhere. The LA cities. Laurel, Lambert, and Lake. Zoom 2. So there's Lambert. See, there's its convex hole. And there's Lake. Okay. All right, so another thing that you could do is we can chain those together. So here's the convex hole. We could also get the difference. So the difference will return anything that's different between two geometries. So what if I did this? New geometry is equal to this, but what if I said dot difference and then did shape? So what's going to happen here? Now, what's the output going to be? I already removed it. Good. Okay. So it's going to take the new geometry and it's going to run the difference method on the new geometry, and I'm feeding it the original shape. So what am I going to get? What's row 0 going to acquire?
Is the difference the inner part?
Look at the help here. Constructs a geometry that is composed only of the region unique to the base geometry, but not part of the other geometry. So, in other words, the base geometry here is the convex hull, and the base part is the convex hull, and the other geometry is the original shape. So what are we going to get?
I see what you're saying now. So you're going to trace. So, you said
The base geometry here is the new geometry, which was the red.
okay, right. I see.
So I just ran it again. Let's see what happens. So I'm going to add my
Which one are you going to so long?
I'm on Lake. I don't have anything. Open attribute table. Do I have any? So Lake just disappeared. Not exactly sure why that is. Right? See, Lake isn't even in this. Let's see if Laurel's in it. Where's Laurel?
What's the original shape?
It looks like Laurel just disappeared. I'll make these red. So I'm not sure why it disappeared, because it should be the difference between those two, composed of the region unique to the base geometry but not part of the other geometry. So I wonder if it's an issue with ArcGIS, and because those geometries, there's some little problem in there. Let's see what happens if we did this. Buffer. I gotta remove it from here first. So we're gonna chain these together and do the difference. But before we do the difference, let's buffer it by like 1 meter, and then calculate the difference. See what that does.
So is the difference the overlay taken away from the original structure, meaning the original shape?
Yeah, it should be the convex hull minus the without the shape in the middle. Now I'm getting an error when I try to run it. Oh, because those aren't even in there. Oh, I see. Because I modified the original. So I probably didn't even... Okay. So this is the problem, because I went ahead of myself. So I'm going to data, export features. I'm going to recreate that that data set. So the problem was the difference between the convex hull and the convex hull is nothing. That's what the problem was. It wasn't anything with the ESRI's code. It was my logic. All right. So now I run that again. Whoops. So now it's not running because it's not copying over the original. It still thinks it's trying to be copied. Okay. So I'm going to call this copy 2. Now I'm going to run it, and I should get the right thing this time when I add copy 2 back.
So did this convex hull take away from that structure here, from that shape there?
Well, there must have been something selected, but that's fine. Okay. So look, here is the original Lake City. Looks like that. Okay. The convex hull is the area outside of Lake City that's still in the convex hull, and this right here is the portion of Lake City that's in the convex hull but not within the city limits. Like that, red. See that? That makes sense? I'm sorry, what? That was the difference. Yep, in the code, that was this difference. Exactly. All right.
What is the difference between that you was trying to explain the difference with that? So the difference is saying that this part really does not belong to Colorado.
Here, I'll show you with Laurel since it's probably a little bit bigger. It's easier to see probably in Laurel. Okay. So I'm gonna add that back. Make it red. Put this on top. Okay. And I'll even make this a little different color too. So we'll make this green, bright green. Okay. All right. So it looks like I've done the exact same thing I did the first time, right? I've got Laurel here, and then I've got the convex hull for Laurel in red, right? Now I turn off Laurel, and look, the part of Laurel that was in Laurel is now cut out of the convex hull. See how it's gone, it's missing? That's what difference did. So now the geometry is just those parts of Laurel that are within those convex hull of Laurel, but are not within the overall boundary of Laurel. They're only in the convex hull of Laurel. The difference is the red part. Exactly. Yep. And you could keep chaining these. You could keep chaining those together. So what I had before was dot buffer. I'm going to do 200. So it'll be 200 meters. And then now I'm going to get the difference of that shape. So run that. So now I'm going to take the convex hull, buffer it, and then find the difference between the original feature. So now I'll add Laurel back. I'll add them all back. But now you can see that the convex hull has been buffered 200 meters past the original.
So you can say the difference is really not Laurel.
The difference is not within the city limits of Laurel. So now I could say that, here, I'll make it red so that it'll be consistent. So now what I can say is the red area is the area that is not within the city of Laurel, but is within Laurel's convex hull or within 200 meters of that convex hull. So that's what the red is. It's the area that's not within the city limits, but it's within, like, we might want to define, like, again, if Laurel, instead of Laurel, if Laurel was the area that an animal was going, we could define the convex hull as the area that might travel in. It's going to travel in that area, and we could then give it another 200 meters just as a buffer, say, well, it might go somewhere in there. That might be its home range. Or in this case, in this particular example, we could say this is like Laurel's sphere of influence, where it might grow to someday. You know, like this is the convex hole, and another 200 meters past its convex hole.
So you might ask for permission to operate, within a convex hole of Laurel and get permission from whatever entity to go outside and maybe for a police operation if something happens, and they might grade you and show them what for it going.
Yeah, I mean, I'm all these are hypotheticals, but yeah, for sure. All right, so what I really wanted to show was, so far what we've done is we've created a copy and we've put it back in the same file. Lots of times when you modify geometries, lots of times when you modify geometries, you actually want to get, you actually want to make a new shapefile, right? And then put the new geometries in the new shapefile rather than putting them in the old shapefile. And so, or the old layer. So let's go ahead and make this example 3. All right. So here, what we could do is return this to being a search cursor. And then what we could do is we could create a new shapefile to hold our new data. Is there a way to create a new shapefile in ArcGIS? Do we even need, I mean, is there a way to do that in the toolbox? You guys have heard of before, maybe? Let's look at the let's look at geoprocessing. Create feature class. Yep. There is a, I guess, create feature class right there. So we want to, if we want to create a new feature class, we can. In fact, there is this drop-down called a template feature class, and that works great for what we're doing. In other words, what it'll do is it'll create a new empty feature class with all of the same records as the old feature class. That's what create feature class does. So if we want, we can look at the help for that. So this is the create feature class. And this is the Python help for it. I'm just going to copy this. And I'll put it right here. So where should I put this? Put this right here. So we're going to create a new feature class. Where are we going to create it? Well, here's our original feature class. Now I'm going to work with that since it's just a search cursor again. So if I want to create it out of that, I can call it, so here's my out path. Let's say I want to put it in the same directory. What do I need to type in here to get to the same directory? Yep, just that. And then the out name that I want to give it, I'm going to call this city, yeah, something like city, and I'll say underscore convex dot shape. Okay, that's the out name. Let's see what these other ones are. Geometry type. What geometry type do I want? Polygon, that's right. And then what the template I wanted to use is this one. So now it's going to make a copy of that. What about these other attributes? Has M, has Z. I don't really need those, do I? The spatial reference allows me to define a spatial reference for the data. But if I use a template, it's going to use that template for the spatial reference. I'm going to go ahead. Right now, I'm going to format, comment out this region. I'm going to go ahead and run this just to show you what it does. So I'm running it. Oh, I forgot to close my quote. Run. And it's going to, all I'm doing in this is creating that new shapefile. So I'm going to add it. What do you think's in that new shapefile that I just created?
This is probably the one you already had. It's all the same information.
Kind of. So I'm going to open up the attribute table. Is there anything in the attribute table? Right. So it's a copy, but it doesn't contain any of the records. It's just the exact same fields. And if I right click on it and I say properties, it's going to tell me that it has the exact same spatial reference. Spatial reference is unknown coordinate system. I guess it's, what's that? It actually didn't give me the same spatial reference. Huh. I thought it was going to give you the same spatial reference. So let's say I wanted to have the same spatial reference. What I could do is make this, because those are optional, but the spatial reference, I could also give it the feature class. In other words, the existing cities. Now it's going to fail because it's going to say already exists. So how can I solve this problem? I could name this 2. What's another way I could solve the problem? Yep.
Is there anything where you can override and change it to true for override?
I can never spell override output right. Override output archive. Equals true. All right, now I'm going to run this, and it should run.
How many quotation marks did you put at the end of the create feature class?
Where?
I think those quotation marks are because there are fields defined there. So in order to get to that last one, you have to have something there, even if it's just saying leave them blank.
Right. Yeah, this has. Usually when you feed it just the blank, you're asking for the default. So what I'm saying here, this is the has M or has Z and has M. So both of those, I think the default's false. So I could have written false, but let's go. No, the help was right here. So that was has M and has Z. And so this is the default. So I gave it disabled and disabled. So it doesn't have an M or a Z. What does that mean? Has an M or has a Z in a shapefile? So a typical point has two coordinates, right? The x and the y. But ESRI allows you to save a coordinate up to 4 points. It has x, y, m, and z. I don't really know what m means. Like it.
Is that math?
Well, it's another value that it could store. It could be time. It's just for a linear measurement value. It's for any other value you want to store in it. By the way, a long time ago, well, not a long time ago, but in today's lecture, when we printed out individual points, see x, y, m, z. That's what these mean. And for this point, there's no m or z value. All right, so it ran, and now we have a data set that represents that, and it should now be in the same spatial reference. So now it's in MSTM. Okay, but it's empty. It doesn't have any records in it. Okay, so we want to put new records in here. We want to put records in here that that represent the convex hull of the data set. Okay. So that's where we get into here. So this saves it out into the same shapefile or the same layer, which is going to be a problem. Now this won't even run. Why won't this run now? By the way, it's going to have a problem on this line and this line, if it ever got to it. Well, why would it have a problem on those two lines if we tried to run this code as it is? Remember, I changed this from search cursor. I changed this from update cursor to search cursor. Why will that cause this to error out? What's that?
Because there's no data in the shapefile, so you can't search anything?
Well, here we haven't done anything yet. Like, you're right that this new shapefile is empty, but we're doing a search cursor actually on the city shapefile. So anyway, the problem is that it's a search cursor now, not an update cursor. So when we try to change the geometry, it's going to say I can't change the geometry because it's a search cursor, and you can't change the geometry. You can't change any attributes. So it says does not support item assignment. We can't assign those values out. Yes. Did you have a question?
Yeah,
Line 16.
On your script, so for SC, okay, why is it city I-10 shape? Or is that just the name of it? Whatever.
That's the name of the shapefile.
Oh, okay. That's just what it pulled up as.
Yes. Yeah. When I forgot where I downloaded it from, but when I downloaded it from wherever, I don't know why it was called City I-10.
Why there was like an I right there. Like right after city.
So you change the term name from search to update cursor, and then fix everything?
Well, it wouldn't fix everything. Now, if I change this to update cursor, it would update this shapefile, which isn't what we want. We want to actually store it in this new shapefile. So basically, what we want to do is read through the old city shapefile, read through every record, and we want to take that information and store it in the we want to store that information in the output shapefile. So we have to create an insert cursor, but which file do we create the insert cursor on? We haven't yet created an insert cursor. Yeah, on the new one. So we want to insert data into the new shapefile, so we need to create an insert cursor on this. So we're going to call that's why I called the first one cursor 2, by the way. Cursor 1. Cursor 2 is equal to arcpy.da.insert cursor. And I got to spell insert right. And then we need to feed it the name of that shapefile, the full path. So what would I type here to get the full path of that shapefile? No, the full path of this needs to be the outgoing file, the file we just created. Right, out underscore path. Could do it like this. This is be kind of fancy, but this will work. Outscore slash dot format out path comma oops what this will do is it'll put out path here and it'll put out name here with a slash in between it. I might have to put an R before it to get it to work. Okay. So it's creating an insert cursor there. And then let's look at the syntax for an insert cursor. Insert cursor. So we create an insert cursor. We also need to give it a list of the fields. Now the only field that we really got from the first one was the name and the shape. So let's just get those same ones. Okay. So we could write fields here and be just fine. So now we'll have our cursor 2 that we can mess with. So let's look at the syntax for what we do. In order to insert a row, we need to give it a tuple. See how this is a tuple? With all of the values that we want to put inside of it. So something like this. So instead of having this line here, we could say, let's call this new geometry diff. So here's our cursor. Do we need to change this from cursor to something else if we're trying to insert it into this in this cursor? Which cursor is it? Do we have a variable called cursor right now? No, we don't. We have cursor 1 and cursor 2. Which of these is it that we're inserting into?
We're starting the old, we're starting group 1 and group 2.
Well, we're taking the row and we're modifying it. We're still creating the convex hole, and we're buffering it and taking the difference. This new geometry, we want to stick it into where? Cursor 1 or cursor 2?
Cursor 2.
Right. Cursor 2. So now we need to construct a tuple to put it in. So we're going to give out our new geometry diff, and we're going to give it, we want to give it the name so that the field will have the name. So how do we give it the name? The name 10 value.
Like that LA up there, like this.
Does that make sense? See how I did the row 1? Why is this the name? Okay, let's go back up to here. For row in cursor 1. What is that? What is that? What's that doing? Not the first row. It does initialize row as a variable. That's true, but then what's it doing? What's the general term for that for row in cursor 1? Yep, it's a loop. So every time through the loop, row is a new value. It's a variable that keeps changing what it is. The first time through the loop, what is row? It's always a tuple, but the first time through the loop, what values are in the tuple row? No, the values. What values does it store? It's a tuple, so row 0 is the first item in that tuple. What is the first item in that tuple? It's the shape. Yep. It is the shape. That's true. It's not its XY coordinates because we said we wanted the entire shape. Okay, so what's row 1? Row 1, what is that? Which I'm using right here. It's the name, right? So what we're doing is we're going row by row and we're getting the shape and the name. The next time through the loop, we're getting the shape and the name. Shape and the name, shape and the name, shape and the name, all the way through. So what we're doing with the shape is we're taking that shape and we're getting the convex hole. Then we're getting the buffer of that, and we're getting the difference. We could write this whole thing. Remember, so I can change this. I'll comment out all these guys. I could just write it like this. Shape dot or convex hole dot.
So is there a shape in shape name for every city, and they don't convex buffer on every city?
Exactly. Every city in the list, which right now, because we did this, are only cities that start with LA. Yep. So this line should work where we take row 0, which is the shape, we do a convex hole, we do a buffer, we find the difference between it and the original shape, which would be that, and then we store that shape, we'd have to change this, and we store the name. So I'm going to run that guy. And I think, do we have to, oh yeah. It's always good practice, especially with insert and update cursors, to actually delete your cursor at the end. So I'm going to delete cursor 1, cursor 2. It doesn't really matter so much with cursor 1 because it's a search cursor. But what that'll do is tell ArcGIS that we're done using it. It's kind of like closing it up. So let's see if this works. Invalid syntax for row in cursor 1. Must have messed up somewhere else. Oh yeah. See,
Are you saying delete the curve in 1 curve 2? Is that closing that coordinates loop, or is that part of the coordinates loop? Insert that delete cursor.
Which one? Sorry.
And delete closes out that for loop.
No, the delete doesn't close out the for loop. It kills the cursors. So when we created this insert cursor here, we sent a message to the operating system that said, hey, we're editing this shapefile. So if you have it open anywhere else, you can't mess with it right now. And so when we say del, we're closing that insert cursor back up. We're saying we're done. So it ran, and now what we should have is a new shapefile that has just those cities that start with L. So we got, or LA. So there's Lake, the city of Lake. There's Laurel. And I don't know where the other one looks like it's up there. And there's the other one, Lambert.
Is this the new attribute table? Is that attribute table?
No, the attribute table is going to be right here. So you can see we have, in the attribute table, we have a bunch of blanks because we only filled in name 10.
Right.
We didn't fill in any of these other values. To fill in those other values, what could we have done to fill in? Like, let's say we wanted to fill in the GOID 10 value. What could... Copy field. Yeah, so we would grow FC a little bit. So we got this GOID 10. I'm going to close this up. GEOID 10. So if we said GEOID 10, I think that's what it looks like. Now we could put row, how am I going to get that? GOID 10. How do I get it? It's row what? Did somebody on the coast said the right answer, I think. I thought I heard somebody say 2. Anyway. So this is 0, this is 1, and this is 2. You see that?
So the count comes from what you're really starting with. If you add a particular field, you count in order where the field is to the land you stay.
Yeah, I put this in the wrong. I mean, it's a tuple, so it needs to go right there, row 2. All right, now it should work, but I might have messed it up. Let's see what happens. Because I opened, yeah, okay, good. ArcGIS fixed it. Okay, so now when I add the data back here, I look at the attribute table. I should have that. Now there's the attribute table, and see how it has the GOID 10 and the Lambert 10? Has both of those.
So row map, you just got to go and just put them all in that first row and do it, or you want nice terms to go on.
Yeah, so if you wanted to get them all, you could do that. There is a way to do that. And you can basically get all the fields. Now, if we put a star here, why wouldn't it work? Anybody have any questions?
If you put a star there, it wouldn't have a beginning or end, would it? It would have a reference point. So we just take all that out and just put a star in there, just one star, it should print all rows, correct?
So the star would give us all the fields, but the problem is that the field, by default, it gives you the centroid instead of the whole shape, which you can't even get a convex hole for a centroid. So we need to give it these fields. So there is a method to be able to get the fields in a file, and that's actually using describe. ArcPy, good. ArcPy describe. So here's the describe data. I wonder if they already have an example on fields. it will give it in order. It actually doesn't matter the order though. But it will give it in order. So what we could do here, this will give us all the fields. So we can describe a data set. So we could go like this. So this will allow us to describe that data set. So let's put an FC here. So we're describing that FC, and then we're going to get all of the fields as a list here by saying desk fields field. I'm going to call this the field list. I'm going to comment all this out for now. Comment out region. I'm going to print that field list. Oh, this is just going to give us a list of field names. So these are all, a better way to do this is to say for field in field list. Print field. Print field dot name. I think we did this earlier. So we're going to get all the names of the fields. So these are all of the fields. Now we know that this is the shape field, but what if we didn't know that was the shape field? We could say that we want to get the field dot type as well. Then it'll give us the name of the field, and it'll tell us if it's the geometry field. See that? Okay. So what we could do is to say something like this. So our fields is going to equal an empty list. What we could do is say if field dot type is equal to geometry. I need to do say equal equals. Why do I need to say equal equals? I do. Yeah, I'm asking. If it's equal to geometry, then fields dot append. And what do I need to do here? I need to append shape at. I'm appending it to this empty list. Else fields dot append field dot name. So what I'm doing is saying if the field is a geometry field, then append the word shape at. Else append the field dot name to the file. And I probably also need to go like, we'll solve that problem in a second here. Let's see, so I'm just going to print fields just to show you what I've done. So now I've got a list of all of the shape fields, of all the fields, and the shape field has been renamed shape at. See what I'm saying? And that way it'll give me the entire thing, not just the polygon. All right. Actually, you know what? We're also not allowed to the FID. we're not allowed to create a new field called FID. So the proper way to do this would say if field dot type. Do you remember what that type was? Equals OID. Then say field. But then we're not gonna pass. Something like that. Well, then let's call it field. It's not going to have. We're not going to be able to write over the OID field. It's just impossible. So let's not even append anything. What is the? Here, I got a better way. That'll work. So what's going to happen now? What apostrophe? Where's that? Oh, that's an exclamation point. Right there? So that means not equal in Python. So if field type does not equal OID, then it's going to do this. So what we're doing there is here, there's no reason that needs to be an else. That should work even if it's not an else. So what we're doing is creating this list, and now we're just not putting in the FID, and it's only going to have. Oh, no, we do need to have an else. Else. Doesn't that work? Does Python need this? There we go. That'll work. So now we have shape and we have all those other values. Okay. So now we have a list of only the fields we can actually do something with. We can't write a new OID field in. That's an auto-generated field. Okay. All right. So now what we can do here is uncomment all this. And what we're going to do is instead of storing the, instead of giving it this list of fields, we'll give it our new list of fields, which will have all the fields in it. But here we have to give it all of the other fields. Okay. And so we have to construct our row to do that. So we'd have to write in probably another for statement, right? Something like for row. Oh, sorry. So for actually, I think we could. I'm going to comment this out because I don't want to do it right now. Let's just print row. Remember what row is going to be, the entire thing, right? Whoops. Yeah, this will actually work well. So row is going to be a tuple that has each of the values. See how it has the polygon object, right? And then it has all of the numbers. So we want to take out the very first item and feed in our item. Since it's a tuple, we can't just go like this. It could just go row 0 is equal to shape now, right? We can't do that. That's not going to work, right? What we could say is something like out row is equal to shape plus, can you add two tuples together? Does that work? Or is it dot join? let's look for the syntax. Join two tuples. Oh, two. Spell two right. How to merge two tuples. It's a plus. Okay, cool. I was right. So we want everything in the second tuple except for the very first thing. So it's row 1 to the end. So that should work. And then this would just be out row. See if that works. I don't know if that's going to work. Yeah, since this technically is like an ArcGIS construct that's almost like a tuple, but it's not exactly a tuple. Let's see if we can convert it to a tuple. Without, I wonder if we have to do a for statement. Yeah, I mean, there might be a more elegant way to do this, but I think the best way to do is just to say for val in row out row is equal to this list, and just say out row dot append val. And this will be out row. Actually, now that this is a list, we can just say out row 0 equals shape. I'm just going to print the out row to make sure. So what we're doing is we're taking the value that's there. We're creating a brand new out row that's a list. And we're going to append the individual values for each one. And then substitute out our new shape. Looks like it worked. Let's see if it actually did anything. Add our data. And we have all of the values in the field. Okay. Now, that's not the only way to skin that cat. Like, I think that if we were going to do this, it might be better to, if we wanted to replace all of the values in the attribute table, it might have been better to make a copy and then of the actual file, and then just do an update cursor. Okay, if that was our end goal, was to make a copy of all the additional data, we could do that probably more efficiently doing it the other way. But yeah, I mean, since y'all asked the question, I wrote those two loops in there to actually build out all the values for those values. What if we wanted to know the area right here? Could we make another field and calculate the area of this new feature into that? How would we create? How do we normally create a new field in a table?
Well, we go and add, we
Right. Anytime you can click add field, anytime you can create a, anytime you can do that, there's a button for it. I mean, there's a tool for it, and that tool can be run in Python. So we could add a new field. So here's the add a new field. I'm going to call this, I'm going to come in here, just going to say file, save as. I'm going to call this example 4. Okay. And then I'm going to add a new field to this feature class. I'm going to do it before I do the cursor. So I'm gonna say that it's going to be it's going to be the same as that. The field name is going to be shape areas or area. It's going to be double. And I'm going to leave everything else a default. So now I'm creating an extra field. And so I'm also going to fields. I'm going to append that field on so I can write to it. And then, or fields.append. And then I'll write that right there. Okay, so yeah, that's fine. Okay. And then that's the very last field. So if I run this right now, it should be empty. Like it should contain nothing. But it should exist. That sequence size, insert cursor, out row, fields. Okay, so I need to give it one more data that is the area. Okay. So in other words, my last out row, yeah, should be one more. So out row is a list. So I just say out row dot append, and I add the area on, the area of the shape. Let's see if there's a way to get that from the shape. So that was back here in the help. My insert cursor, yeah. Okay. Let's see if area is in here at all. Get area returns the area of the feature using a measurement type. That's optional. See how the squiggly bracket means it's optional? I don't know what measurement type I would want to use besides maybe they mean geodesic or regular. I'm just going to get the regular area. So what I can do is get the shape.getArea as the last element. And if I run this now, I have the area of the convex hole that is not part of the city limits. All right. So now I have that attribute table. So the very last one here is my new shape area field. So which one of these has the biggest area? That's not part of the city limits. Looks like it's that one, which is Laurel, which makes sense because it's the biggest city, right? What if I wanted to rerun this again, but I wanted to, let's say I want to rerun this again, but I want to do this for every single city in all of Mississippi. What would I change?
Where you want to put it into a you want to,
There's already a for loop. This is a for loop right here.
but you want to stick in whatever inside the city. So,
Right now, it's only running for what? For which cities is it running for?
LA.
LA,
LA. So if it weren't running for all the cities, how do I change it so that it's running for all the cities rather than just LA?
Remove LA.
Put the star.
put a star in there. Put a star in
The
there.
percent is actually, in this case, the wild card. So I could just do percent. Or I could just get rid of this altogether, and it would do everything. Okay? But I'm just going to do percent. So now I'm going to run this, and I get every single city. It's going to take a little bit longer to run, but it's going to run it for every single city that there is. And it's going to calculate that, the part that's outside of the city. Now, what might be more interesting, again, this may not be like super interesting, but what might be more interesting is to get the ratio between the original city size and the part that's in the convex hull that lies outside of the city. So I could do that as row 0 dot get area. And what that's going to do is get the area of the original city and find out what the intersected area is, or the difference area is in relation to the original area. In other words, how much larger is its convex hull than it is itself. I'm also going to take out the buffer part and run that.
It's gonna come up with a number or something.
It's going to come up with an index where it's going to be an index of the size of the convex hull relative to the size of the entire object itself. Okay. All right. So let's look and see which city in all of Mississippi has the greatest ratio between the original size of itself and its convex hull. So I'm going to open up the attribute table and sort on that last field. The other direction. So there was a city, it's Pelahatchie, where the convex hull of Pelahatchie is actually 2.5 times larger, or 2.8 times larger than the city itself, right? So that's kind of weird. And then the second one was the next city over, which we already looked up. What was it? Morton, and so on. Okay. Now look, if we go all the way down to the extreme other end, we'll find this city, which is Gatman Village. Let's zoom to Gatman Village. All right. So why is the convex hull almost the same in that case? There's just barely a difference. What's that?
Because it's not an odd shape, it's a more square shape.
Right, exactly. So what we've done is we created an index of odd shapes. So in other words, we've come up with a way, or our code has come up with a way to quantify the oddness of a city. Right? So you could use this to, like, let's say that you wanted to use this for voting districts. You could come up with the oddest voting districts that there were. In other words, the shapes that were the most strange. What do we call a voting district that looks really strange? It's not really something we learned in this class, but
Yeah, so just
it's a term that Benjamin Franklin actually came up with.
what's that thing they call
it's not. I guess it's not super important, but when they make weird voting districts, sometimes we refer to it as a gerrymander. You ever heard that term before?
Yeah, they do that because it actually changes. You can use that to change where the votes of that district will go.
Right. So not all ad-shaped voting districts are necessarily gerrymandered, and some of them are, I guess you could say, gerrymandered for a reason. Like they're trying to capture a particular voting demographic. But anyway, what our script could do, the utility of this script, could be to detect a gerrymandered
For certain type of people,
gerrymandered.
all ice, all gas, all this color, all that. So it don't have to be a geometrical shape for that, the reason why you do a convex hole. It could be based on people, right? Correct?
Yeah, my point here is though that that what we actually did today, where we wrote a script to quickly identify weird shaped things, has application in lots of areas. So one area might be voting, but we could also, for example, we could look at different species, and if this represented tracking data for different species, we could see if species in one area had a more irregular, is probably a better way to say it than weird, had a more irregular home range than species in another area. So looking at the difference between some standard geometry, which a convex hole could be considered a standard geometry, and the actual geometry for that thing is often one way to do that, to quantify how irregular a shape is. And that really doesn't have anything to do with scripting. It's just a general geographic principle to compare a standard shape to to all the individual shapes and see how irregular it is. Sorry, were you about to answer?
It can be used to group, as you were saying, group certain things in a geometrical shape to quantify whatever you're looking for. This is the grouping tool, but everything within the shape, you can design that based on buffers and stuff. You can buffer in a particular one shape item based on this representation.
Yep. Yeah. And then also, by the way, you could, if you buffered a shape, the more you buffer a shape, the more regular it becomes, the more easier it is to contain in a convex hole or a regular shape. Eventually, as you buffer a shape larger and larger, all shapes tend to be circles. Okay, so that script was really just practicing taking one data set, modifying its geometry slightly, and putting it into another data set. Okay. Before we take our break, there's one more thing that I'd like to go over, and that is just writing into an empty shapefile data, creating new data out of I don't know, a list of data sets or a brand new data set. Because sometimes you'll get data that is geographic, but it's not yet a shapefile. And so I'm just going to hit new file here and save this as. And to do this, I'm actually just going to use some of the examples that are already in ArcGIS on writing geometries to go over. So if I go to Arc, I think I have a link in GitHub. Yeah. So here we are on writing geometries. It is possible to create your own geometries just by creating an ArcPy array of points. So you could take a bunch of points and make them either points, lines, or polygons. Now, you can make multi-part geometries, but you actually can't do interior rings. So you can't make something like, you can make something like Hawaii, but you can't make something like GHY, where there's a line inside of another line. Okay. You can't do it this way. To do it that way, you would have to you'd have to construct a geometry and then construct rings inside of the geometry to do it. But there's tons of features that don't have features inside of features. And so this is a valuable way to learn how to do it. Okay. All right, so let's just look at these examples here. So here we have a new, what they've done is they have a feature class called roads, and they're taking roads, they're taking the shape, and they're feeding it an array of points. What do you think that's going to do? It's an insert cursor.
It's creating a road, a shape of the road.
Yes. How many new records is it creating?
Each XY point would be a record.
Each XY point.
So it's two? Would it be two?
No. So each XY is a point, and this is a polygon. So this array is a single line inside of that shapefile. Just one line. Here, let's. I'm going to copy this example. Here. So that's a simple point one. If we just have points to deal with, but let's do the first one where it's a polyline. Okay. And then this would be a pretty complex polygon, not super complex. It's actually. Okay, so let's do the first one because it's really kind of basic. All right. Why will it fail if we just try to run this right now?
We don't have any of our information yet.
We don't have any of our information. I'm not quite sure what you mean there, but you're probably on the right track. I
Like our data, you don't have any of our actual data from our program in there.
we don't.
Random stuff.
Yeah, maybe what you're saying, I'm just not understanding, is that we don't have a roads layer, especially at C data gdb.gdb roads. We don't have that.
That's too general.
It's not too general. It's very specific. It's saying you have a data set called C data gdb.gdb/roads, and we don't. So if we try to run this, it's going to say I couldn't find a data set at that location. Okay. It's an error. See how it says can't open that? Doesn't exist. So we can do one of two things. We can create our own data set called roads, and maybe that's what we'll do. So I'm going to go to this create feature class and say, let's create a data set. I don't know that we can create one there. Let's create it. Here, let's get all this. Let's just keep working in the same directory. So make this big.
Those reference points gotta go on top of something, right? So we look at the line, but the line gotta be put on top of something.
Not on top of something. It just needs to go in a file that actually exists. So we're going to call this lines.shape. So we're going to save it in this same directory. We're going to call it lines.shape. And it's going to be, we're going to make it a polyline. And now we're not going to feed it a template at all. I'm not going to give it a template. Should we give it a spatial reference? I wonder if we can just write 4326. Let's see if that'll work. Why don't lines need spatial reference? What is a spatial reference? Actually, we can actually just copy this line up, put it right here, and then say spatial reference. What's a spatial reference? No, I'm not saying that. Coordinate system, exactly. The spatial reference is the coordinate system that we plan to use. So 4326 is latitude, longitude, WGS 84. That's just the code for it. Those codes used to be, you had to like define a lot more stuff. It's nice to have the codes. So this is going to create latitude, longitude, WGS 84, and it's not going to use a template, so it's only going to have some default fields. It's going to have a shape field, it's going to have an FID field, and it's going to have one other field called ID, but just because it has to. So now if I run this, FC is not defined. Where does it say FC? FC right there. So I'm going to say C. So FC equals R. Out underscore path, comma, out underscore. All right, so now that should work. Lines already exist. Okay, how do we solve that? Well, we can actually go delete it, or we could just put that line in there. So now although it already created it, we have a copy of it. I mean, it'll overwrite the copy of it. So now it ran through. So let's see what we created. I'm going to turn this off, zoom out here. I'm going to add that in. We just called it lines. I got to refresh. There we go. Let's open the attribute table. Oh, it didn't add the row, but it did have FID, shape, and ID. Cursor.in. I wonder why it didn't save that data out. Now it's saying it can't get an exclusive schema lock. Pretty sure it's because it didn't have the del statement in there. Because especially when you do insert or update cursors, it's still not saving that out. It doesn't look like. Oh, there it is. It saved it that time. I don't know why I put it up there. I want to put it down there. Okay. There it is. See, you created that line between Raleigh and Richmond. See that? I'm going to make that line bigger. So the line it created, that was this line from there to there. Remember way back when we did that? Didn't we do a lab where we read in files from the internet, or we read a file and we found out coordinates from the internet from a bunch of cities. Do you remember that?
Yeah.
Which week was that? Location.py. Yeah, this gets a location based on the World Geocoders survey. Okay. So here's my little function that does that. I'm gonna rename this. Wow. Save as. I'm gonna call this example 6. All right. So I'm gonna take the code from earlier that gets the location for Hattiesburg, and it's going to get a. Well, here let's comment this out for a second. Okay, so that gives us an x and a y coordinate that looks a lot like this x and y coordinate. So what I want to do is I'm going to change this so that I have a list of cities. And I could make a file that reads them in, but let's think of some cities off the top of our heads. Okay, so I've got. So does somebody else have a different city? Okay. Okay. Any other cities? Poplarville. Okay. I mean, we could even open up an insert cursor and get all the cities in Mississippi, do a road trip. But let's just do those 3 for now. Okay. So instead of this line, we're going to say arcpy.point, and we're going to give it, well, here. So we're going to go for, yeah, this, see this, what data type is this right here? Like what I'm highlighting on right there. No, what does this right here mean that I'm creating? See the bracket, the square bracket? A list, right. So what I'm doing is giving it a list of points. So I could do something like this where I say for city in cities, and then say get address location. This is going to be, oops. What does get address location return? Did anybody see? Yep. Exactly. X and Y. So what I could do is say points list. Points list is equal to an empty list. So how do I append this? What I could do is say points list dot append, and then I could feed it the point, except for I don't want it to be these coordinates. I want it to be right. This actually has to be city. So now I say x comma y, and then my array now becomes my point list. So my point list held is a list, and I turned it into a list of points, and then I took that array, and instead of giving it the list of points that were typed out, now it's going to have a list of these points. I need one more thing there. Okay, so it's going to give it a list of those points, and then it's going to store those in this polyline. This is a insert cursor, so it's just going to simply add those to the already existing. I actually want to delete it, so I'm going to go in here. M7. No, that's not the right place. This one. Nope. C temp 7. I want to get rid of it. So all these lines, just going to delete. Now I'll rerun my script, and what it's doing is it's going to go out on the internet and find the location of Hattiesburg, Jackson, Poplarville, and it's going to feed those values in. Point list not defined. I spelled something wrong. There we go. Run it again. So now it ran, and I can add that data in, zoom to it, and I've gone from Hattiesburg to Jackson to Poplarville. So I created a line that did those three data, that did those that went to those points. So that was my list of cities.
So if you want to go back to Hattiesburg, you could do it again.
Yep. Hattiesburg, comma MS. I gotta. It won't. If it's open in ArcGIS Pro, it won't let me edit it. So I gotta remove it. That's what I've been doing. So now it'll go from Hattiesburg to Jackson to Poplar back to Hattiesburg.
It's there on Google Maps through navigation, but
So that. Now, what if I wanted to make this a polygon shape file and just draw a polygon between those three coordinates? How could I change this code? What would I have to do to change? What line would I have to change to make this so that it was a polygon shape file? Yep. That's really the only change I have to make. It's still going to be called lines.shape. If I wanted to rename it, I could. It'd probably make more sense to call it polygon.shape. But now, what does it say? Cannot alter multi-part geometry type. So, that I also have to delete. I have to delete it because what it's saying is that it's already there and it's already a line. And now it's open in Python. I have to close Python now. It's easier at this point to just rename this. And then run it. But I don't have to name it something else other than the fact that I accidentally didn't delete it and now it's like open. I also created a polyline here, and I need to create a polygon there. That's actually the problem. So it wasn't keeping it up. Well, I called it. This is a variable name, so technically I don't need to change that. But see, it ran. But that would probably be helpful to change because it would be better. Oh yeah, it's the other one. Thank you. So there's the polygon that we just created. Okay. Now you don't actually have to make your polygons close. ArcGIS will solve that problem for you. You don't have to have this here, but it's helpful. For you, you can do it. Okay. So yeah, we could say polygon here if we wanted to, and polygon here, but that's just the name of the variable. We could also just call this my shape or something. That way we'd make it general so that if we wanted to rerun that, it would work. All right. So yeah, so we're combining a few different things here, and we're getting we're getting an output layer. Now, we could use this for all sorts of things, like what if we wanted to create a, that's the wrong one I just added, but what if we wanted to create a polygon layer that was from, we had a big file that had a bunch of points that represented where somebody recorded a GPS, and we wanted to find out the area inside of where they went. Well, we could do it that way, right? And it's actually easier to do this way than it is any other. You could probably figure out how to do it in the GUI, but it would take you a long way. You have to make sure your data is organized a way that ArcGIS could read it. You read it in as a CSV. It would turn those into points. And then there's probably a tool that says, okay, take these points and find the polygon that represents those points. There's probably a tool for that. But you'd have to write that over and over and over again. Whereas if we were just going to read a bunch of points from a file, we could write that in a lot less code than we even have on the screen right now. Okay, so let's go ahead and take a 15-minute break, come back at 2:40, and then we'll go over the lab assignment, which we'll do a fair bit of it together, and it'll be similar to what we've just done here. Okay, very, very, very similar.
Is there some data that we have?
No, the data that we'll use is like this case. We're gonna use a web service, so you don't need to download any data. Hey, did the tests come at all?
No, I haven't heard yet.
Okay.
She has my cell phone, so she's gonna call me on my cell phone number. So she's gonna call me whenever they come in.
Okay. All right. I need to use the restroom, but I'll be right back, and we'll come back at 40 after. Oh, I'm going to stop the recording.